look up at the night sky, what do you see? A vast expanse peppered with tiny points of light. Each one of those points a star, a distant sun burning bright in the darkness of space. These celestial fireflies are more than just pretty lights. They are the building blocks of galaxies, the cradles of planets, and the source of life itself. Their stories are tales of immense energy, unimaginable gravity, and the slow, relentless march of time. From their birth in clouds of gas and dust to their explosive deaths and the strange remnants they leave behind, stars live lives of drama and wonder. Tonight we embark on a journey to unravel the mysteries of these cosmic giants. We will explore the forces that govern their lives, from their fiery births to their silent, fading deaths. Get ready to witness the awe-inspiring life cycle of stars, a story written across the cosmos for billions of years. Join me as we delve into the heart of these celestial wonders and uncover the secrets they hold. Our journey begins in the cold, dark corners of the cosmos, in vast clouds of gas and dust known as nebulae. These stellar nurseries, often spanning hundreds of light years, are the birthplaces of stars. Don't let their darkness fool you. These clouds are anything but empty. They are filled with the raw materials of creation, primarily hydrogen and helium, the most abundant elements in the universe. Within these swirling clouds, gravity acts as a sculptor, slowly pulling together clumps of gas and dust. As these clumps grow, their gravitational pull strengthens, drawing in more and more material. Like a snowball rolling down a hill, the process gains momentum, pulling in everything in its path. Over millions of years, these collapsing clouds, known as protostars, become denser and hotter. The temperature and pressure at their core continue to rise, setting the stage for the most spectacular event in a star's life, its birth. Deep within the heart of a protostar, a dramatic transformation is about to occur. The intense pressure and heat, reaching millions of degrees, have created the perfect conditions for nuclear fusion. This is the process that powers the stars, a stellar engine that will burn for billions of years. In nuclear fusion, hydrogen atoms, the simplest and most abundant element in the universe, are forced together under unimaginable pressure. This fusion creates helium, a slightly heavier element, and releases a tremendous amount of energy in the process. This energy, in the form of light and heat, radiates outward from the star's core, pushing against the inward force of gravity. With this first burst of fusion, a star is born. The protostar, once a collapsing cloud of gas and dust, has ignited into a brilliant shining beacon in the cosmos. It is a delicate balance, a cosmic dance between gravity pulling inwards and the outward pressure of fusion. This balance, this delicate equilibrium, will define the star's life for millions, even billions of years. Once a star achieves nuclear fusion, it enters a long, stable period known as the main sequence. This is the prime of a star's life, where it spends the majority of its existence. During this phase, the star exists in a state of hydrostatic equilibrium. The outward pressure from nuclear fusion in its core perfectly balances the inward pull of gravity. Think of it like a balloon. The air pressure inside the balloon pushes outwards, keeping the balloon inflated. This outward pressure is balanced by the tension of the balloon's skin, pulling inwards. A star, in its main sequence, maintains a similar balance. The size and temperature of a star determine its position on the main sequence. Hotter, more massive stars burn brighter and have shorter lifespans. Cooler, less massive stars, like our own Sun, live longer, more leisurely lives. But what happens when the fuel runs out? Section 5. The fate of a giant. When a star's fuel runs low. As a star ages, its supply of hydrogen fuel in the core begins to dwindle. This marks the beginning of the end of its main sequence life. With less fuel to burn, the outward pressure from fusion weakens and gravity begins to gain the upper hand. The star's core contracts, becoming denser and hotter. This increase in temperature and pressure is enough to ignite the fusion of helium, the byproduct of the previous hydrogen fusion. The star is now burning helium as its primary fuel source. This new source of energy causes the star's outer layers to expand dramatically, transforming it into a red giant. Red giants are colossal, their diameters stretching hundreds of times larger than our Sun. If our Sun were to become a red giant, It would engulf the orbits of Mercury, Venus, and even Earth. Section 6. A blaze of glory supernovae and the birth of neutron stars. The fate of a star after its red giant phase depends on its mass. For stars like our Sun, the journey ends relatively peacefully. They shed their outer layers into space, forming beautiful planetary nebulae, and their cores contract into small, dense objects called white dwarfs. However, for stars much more massive than our Sun, the end is far more dramatic. These stellar giants, after their red giant phase, continue to fuse heavier and heavier elements in their cores, from carbon to oxygen, neon, and finally to iron. Iron fusion, unlike the fusion of lighter elements, does not produce energy, it consumes it. This marks the beginning of the end for these massive stars. The core collapses in on itself in a fraction of a second, triggering a shockwave that rips the star apart in a cataclysmic explosion known as a supernova. Supernovae are some of the most energetic events in the universe, briefly outshining entire galaxies. The intense energy released in these explosions can forge elements heavier than iron, scattering them into the vast cosmic void. From the ashes of these stellar explosions, a new cosmic entity can arise, a neutron star. Section 7. Stellar remnants, white dwarfs, and black holes. After a star's life comes to an end, it leaves behind a remnant, a testament to its former glory. These remnants, depending on the mass of the original star, can take many forms. White dwarfs, the remnants of stars like our Sun, are incredibly dense. Imagine squeezing the entire mass of the Sun into an object the size of Earth. That's a white dwarf. These stellar embers slowly cool over billions of years, eventually fading into darkness. Neutron stars, born from the heart of supernovae, are even stranger. They are composed almost entirely of neutrons, subatomic particles packed together as densely as physically possible. A teaspoon of neutron star material would weigh billions of tons on Earth. Some neutron stars, known as pulsars, spin rapidly, emitting beams of radiation that sweep across the cosmos like cosmic lighthouses. The most extreme stellar remnants are black holes. Formed when the most massive stars collapse at the end of their lives, black holes are regions of space-time where gravity is so strong that nothing, not even light, can escape. These enigmatic objects warp the fabric of space and time, challenging our understanding of the universe. Section 8. From stardust to life, the cosmic legacy of stars. Stars, throughout their lives and even in their deaths, play a crucial role in shaping the universe as we know it. They are the cosmic engines that forge the elements necessary for life. The carbon in our bodies, the oxygen we breathe, the calcium in our bones, all were created in the nuclear furnaces of stars. Supernovae, while marking the end for massive stars, are also responsible for seeding the universe with these heavy elements. The shock waves from these explosions can trigger the formation of new stars and planetary systems, enriching them with the building blocks of planets and life. We are, in a very real sense, children of the stars. The atoms that make up our bodies were once part of these distant suns. Their lives and deaths have shaped the cosmos, creating the conditions necessary for life to emerge on at least one planet, our own. Section 9. A universe ablaze, the enduring cycle of stellar evolution. The life cycle of stars is a continuous process, a cosmic dance of birth, life, death, and rebirth. From the stellar nurseries where they take their first breath to the dramatic supernovae that mark the end for some, stars shape the universe we live in. As we gaze up at the night sky, we are witnessing this cycle in action. New stars are being born even as we speak, while others are reaching the end of their lives. It is a reminder of the vastness of the cosmos and the incredible forces at play. The next time you look up at the stars, remember their story. They are not just points of light. They are the building blocks of galaxies, the cradles of planets, and the source of life itself. Their story is our story, a cosmic tale written across billions of years and light years, a testament to the beauty and wonder of the universe we call home.